Hey guys, welcome to the channel. In today's video, we're going to look at a Leetcode problem, and the problem's name is last stone weight. In this question, we are given an integer array called stones, where each element in the array represents the weight of the stone. So we perform an operation where we select the two heaviest stones in the available array and smash them together. Suppose if the two stones' weight are x and y, if x is equal to y, then both the stones are destroyed. If x is not equal to y, then the difference between the stones, that is y minus x, will be the new weight of the stone. And finally, at the end of the game, there is at most one stone left. And since they mentioned it is at most, it means that there might be a case where no stones are left. If no stones are left, then we return 0 as the output. There are two hints given inside the problem statement to decide which data structure you have to use. It is mentioned that you have to select two heaviest stones in one operation, and also it is mentioned that you will be left with at most one stone. So you can implement this question as a max heap using a priority queue, where the elements inside the queue are sorted in decreasing order, that is descending order from heaviest to lightest. And then using the pole method, you can get the top two heaviest stones and smash them together, and if there is a weight remaining, you can put the difference back inside the queue, and finally you will be left with at most one stone, right? So you can use the pole method to get the last remaining element inside the priority queue, which will be our output. Now let's take a look at this example and see how we are getting the output. I've taken the same example given to us. This is the stones array. Now we need to add these elements inside the priority queue to access the two heaviest stones. So by default, a priority queue in Java is a min heap, but we need to implement the priority queue as a max heap. So let's create a max heap. So we'll iterate through the stones array from left to right, and we access one element at a time, starting from 0 till 5. So this is the max heap. Now we are going to access the max heap until the priority queue size is greater than 1. As soon as you find one element or less than one element, that is empty priority queue, you can end the iteration. So we take the first element and the second element. We check if the first element is 8, which is greater than 7. So find its difference. Its difference is 1. So using the pole method, you get the top two elements, and it will also remove those elements from the priority queue. So 8 and 7 will be removed. And now you add this 1, which is the new weight of the stone, into the priority queue. But this is a max heap, right? So it will be sorted. Now go for the next iteration. We take the top two elements again, 4 and 2. 4 is greater than 2. So the difference is 4 minus 2, which is 2. So add this 2 back into the priority queue. So using pole method, you access them. So these two will be removed. 4 and 2 are removed. And this new 2 is added to the priority queue. Now go for the next elements. This is stone 1 and this is stone 2. 2 is greater than 1. So difference is 1. So add this 1 back into the priority queue. Remove these two existing elements and 1 will be added. Now using pole method, access the top two elements 1 and 1. 1 is equal to 1. So there is no need to add a new weight. So using pole method, these two are accessed and also removed from the priority queue. And now you see the size of the priority queue is equal to 1. So you can end the iteration. And using the pole method, you access that element, the leftover element, which is 1. So this will be returned as the output. Now let's implement these steps in a Java program. Coming to the function given to us, this is the function name and this is the input array stones given to us, and the return type is an integer representing the last remaining stone. So let's start off by creating a priority queue where the queue will contain integers. By default in Java, the priority queue is implemented as a min heap, but we need a max heap, right? So I'm creating a comparator and overriding the compare method by returning the heaviest stone first, then the lighter stone. You can also use the collections.reverseOrder method to implement the max heap, or you can also use the lambda method, but this is the default way how you can override the compare method using the comparator. And now we are iterating through the input array stones and adding the stones into the priority queue. Now the priority queue will sort them as max heap, that is from maximum to minimum weight. And then using a while loop, I'm going to perform operations on the priority queue until the size of the priority queue is greater than 1, which means there should be at least two elements. As soon as there is one element or less inside the priority queue, we end the while loop. So inside this while loop, I'm getting the heaviest stone and the second heaviest stone. And then I'm checking if stone 1 is greater than stone 2. Then I'm adding the difference, stone 1 minus stone 2, into the priority queue. If stone 1 is equal to stone 2, then you can ignore it. There is no need to write the else block. And once you come out of the while loop, you're going to check if the priority queue is empty. If the priority queue is empty, you have to return 0. because it is mentioned that if no stones are present, return 0. If there is one stone present inside the priority queue, which is our answer, then I'm using the poll method to get the topmost element from the queue and return it as the output. Now let's run the code. The test cases are running. Let's submit the code. And a solution has been accepted. So the time complexity of this approach is O of n log n, and the space complexity is O of n because you're using a priority queue to solve this question, where n is the length of the stones array given to us. That's it guys, thank you for watching and I'll see you in the next video.